Hello and welcome everyone to today's session. Today in this session we will be talking about this project on C Hello World. So all what we've been doing in the previous classes is all about the shell, how to navigate the shell, some important codes or commands that you need to know to move around and play with stuffs within the shell, right? So today we are going to begin our journey on C programming. C programming is one of the most important programming languages. It's used to do a lot of things. Like I said, you can use the C programming to do. So this is what we'll be introducing you through today, which is the C Hello World. So let's move to the task resources and see. So these are the resources here. You can just go ahead and go through the resources, read them. Some are videos, you just have to watch them, and some are kind of text, so you have to read through to be able to understand. So I just want to go directly to the tasks. But before that, I want to explain two concepts for you. The first one is the C program compilation process. This is very, very important. I just want to explain this concept in brief. Okay, so what do you understand by compilation? Actually, the compilation process in C refers to the series of steps that a C program goes through to be transformed into machine code that can be executed by a computer. Okay, so you all know that when you write the code using a C program, right, then for the computer to be able to understand that program, it needs to convert that code you wrote into a machine code. Okay, so it has to transform it into zeros and ones for the computer to understand. So that is basically what compilation is. But this compilation involves some series of stages or steps. Okay, it's not done at a time. So there are some steps that it needs to follow before it completes the compilation. And these steps are very, very important as well. The first step is the pre-processing step, or let me say the pre-processing stage. So the preprocessor is the first step in the compilation process. It modifies the source code according to any preprocessor directives. So you all know that at times when you are to write some, let's say you want to write a C program, we all start by doing something like this at times, #include, then we include the standard library in which we are going to use. So this hash here, this is telling the compiler that this is a preprocessor directives. So and this need to be pre-processed before moving to the next steps. Okay, before moving to the next step. So this is just what the pre-processing does. Okay, it modifies the source code according to any preprocessor directives. That is the #include that are included in the code. So whenever there is a #include in your code, it is pre-processed in this stage. So the preprocessor reads the source code and performs operations such as replacing, includes, files, macro expansion, and conditional compilation. So these are also very, very important things that the preprocessor step is capable of doing. So the output of the preprocessor is modified version of an original source code. So after writing your code and it passed the preprocessor stage, it's just that it's creating another version of your code, but just that with some little modification. So after the pre-processing stage of your code, this hash will not be available again. Okay, it will leave. So this preprocessor directive will leave because it has already been pre-processed. So the next stage is the compilation stage. So the C compiler converts that pre-processed source code into assembly language. Okay, so the compiler reads the modified source code, that is the code we generated above, right, and generate an assembly language file which contains a sort of instruction that can be executed by the computer processor. Okay, so this assembly language file that this compiler is going to generate is not human readable. You cannot read it. Okay, you cannot read it. So that's just what the compilation does. It also modifies the above file that we generated from the pre-processing stage. So the next stage is the assembly stage. The assembly stage converts the assembly language that's that's the code we generated in the compilation stage. It's converted into machine code. The assembler takes the assembly language file and translates it into machine code, which is a sequence of binary instructions. Okay, it's a sequence of binary instructions that can be executed directly by the processor. Okay, so it is also not human readable. You can just go ahead and go through this video here, be able to understand this this compilation process in details. Okay, I'm just trying to explain in brief. So the next or the final stage is what is the linking stage. So the linker combines the machine code from multiple object files and resolves any external symbol references, okay, to produce a final executable program. So in most cases, a C program is composed of multiple source files, right, that are compiled separately. Yes, mostly you have a file here, a file here, a file here, and you want to all compile them to be a single file. So the object files generated by the compiler are then combined by the linker to produce a single executable program. Also, the linker resolves any external symbol references such as function calls and variable references to produce a final executable file. So this is just in brief what the compilation process is. And finally, or let me say, yes, finally actually is the execution. Okay, the execution. But the main part of compilation process are the pre-processing stage, compilation stage, assembling stage, and then the linking stage. So these are the very important part. Just make sure you read through and understand all this pre-processing stage, compilation stage, sorry. So the next thing I want to is the Betty linter. So what is this Betty linter? Betty linter helps you to what? To write your code in a standard format. Okay, it helps you to write your code the way professionals write their codes. That's just the role of this Betty. So if you write your code that is not according to Betty standard, it is going to prompt an error for you, and you'll never get your checks correct. The checker will fail in some cases. So as from now on, when you are to write our code, you have to write according to this Betty this Betty format. So there's a format for this Betty. You can go to this Betty repo and you'll be able to get every documentation about Betty. You'll be able to see what Betty is capable of doing and how you can write code to meet Betty standard. It is very, very important actually, because Betty standard is just like the main standard of writing the code. It's very, very important. As a software developer, you'll not be writing code that will look like you are not a professional, right? So it's better for you to start learning how to write code in the standard way. So that is why Betty is here to help. Okay, but before we use Betty, we have to install this Betty and set it up on our machine. So now let's begin the process of installing Betty. They said we should go to Betty repository. So click on this to go to the repo. After opening the repo, it says clone the repo to your local machine. Okay, so this is the repository here, right? So all you are going to do is just press this and copy this code here. Just copy it here. Okay, so now they said we should clone it. So let's clone. So we are going to use git clone. So we are going to paste this URL that we just copied. Okay, right? So press enter to clone it. Okay, so now you can see it has been cloned. So what again? They said we should cd into the Betty directory. So cd, then then Betty, right? Oops, okay, sorry, the B should be in capital letter, right? Caps Betty, right? Okay, so now we are in the Betty directory. So install the linter with sudo /install sh. So let me just copy. So just paste here. Okay, so press enter. Okay, so you can see it says all set, right? So the next thing is vi, a new file called Betty. So we are to create a new file called Betty and copy the script below. Okay, so let's say vi Betty, right? And then we are to copy this script here and paste it inside our new file. So copy, then paste here. Okay, so what next? Saved, exit file and change permission. So we are to save and exit WQ, right? So we are to change permission to apply to all users. So we can just use this. I'm sure we are all familiar with this command, right? So we have to paste this, then press enter. Okay, it's done. So the next thing is move the Betty file into /bin directory or somewhere else in your path with sudo mv Betty. Okay, so you can just copy this. Let me just copy this and then paste here. Okay, so now it's done. So now we can just type in Betty and then our file name and the Betty linter will run. So let me clear my screen. Let me cd out of the Betty repo. So let's say I want to check. Let me see if I have a file here. Yes, I have a readme file, right? Let me just try running Betty on it, even though it won't work because it's not a C file, right? I just want to ensure that Betty is really installed. Okay, so Betty readme readme.md. Okay, so you can see definitely Betty has been installed. Had it mean Betty is not installed, it will display that Betty is not recognized. So this shows that what Betty has been installed. Okay, so now we have successfully created or installed Betty on our computer, on our machine. So the next thing is to move to the tasks. So this first task here says write a script that runs a C file through the preprocessor and save the result into another file. So normally we are going to use what? GCC as our compiler. We are going to use GCC to compile our C programs here. So like I explained earlier, that the compilation process involves 4 basic stages, right? 4 important stages: the pre-processing stage, the compilation stage, and the assembly stage, and the what? And then the linking stage. So this script here we are asked to write should what? Should go through the preprocessor only. It should not move to the next phase. So after the pre-processing stage, the compilation should stop. So we are going to use what? GCC for this compilation, and the file we are going to compile is what? Is inside this C file. This is inside this variable here. Okay, file. So let me show you something here. So this is the different flags. Just type in man, then GCC, you'll be able to see all these things. So these are the different flags that you can use with GCC. Everyone here has its own specific functions. So I'm interested in this -e. Why? Because -e stops after the pre-processing stage. This tells the compilation to stop where? Immediately after the pre-processing stage, which is what we are asked to do here. So I can just simply say GCC, then what? Then the file name. So the file name is what? Is inside this variable here. So I'm just going to paste this here. So I'm compiling using GCC this file here, which is inside this variable here. And what? Since I'm stopping after the pre-processing stage, I'm going to type in this flag here, which is what I just showed you here, right? This -e. It should stop after the pre-processing stage. So I'm going to type it, and then what are we asked again? That the output should be saved in the file C. Okay, so this means if I run this command here, it's just going to what? It's going to compile, and the file name will be the same as the file inside this. The new file will be the same as the existing file, but here we are asked to what? The output should be saved in another file, and the file is what? Is C. So to change the file, you have to use this flag O. Let me show you if it's here. Okay, so you can see place output in file, then the file name here. Okay, so the output should be what? Should be placed in another file, not the same file in which you are compiling from. So that is what we asked here, and what the file is what? Is C. So I can just type in C here. Okay, so that's just how the command should look like. So let me open the file and write our script. Okay, vi, let me copy it, vi, then paste here. Okay, yes, okay. So now let's type in the command. The command is GCC, then the file name, which is what? Which is inside this variable here called what? Sorry, called C file. It is called C file. Then what? Then this flag -e. Okay, then -o, right? -o, then what? Then C. So I've explained this. Like I said, this is going to what? Use GCC to compile the file which is inside this variable, and then tell the compiler that to stop the compilation after the pre-processing stage, and I want the output of the compilation to be saved inside this new file. That's just what this command does. So let's save and exit. Okay, so now let's convert it to executable. All right, so let's add. Okay, so yes, you can see now it's working. So let me just call it preprocessor. Okay, so let's push. All right, so now let's check the code and see if it works. So check. Yes, so you can see the checks are now correct. Okay, so this is how you'll be able to do this thing. Just go through these flags. It contains everything or all the things you need to know about GCC. Okay, these are the different flags that you can use. So now let's move to the next task. It says what? Write a script that compiles a C file but does not link. It compiles it. Like I said, the pre-processing, we have the pre-processing stage, we have the what? Compilation stage, we have the assembly stage, and then what? The linking stage. So this means that the file is going to what? Pass through the pre-processing stage. It's going to what? Pass through the compilation stage, right? Pass through the assembly stage, but it will not what? It will not go through the linking stage, because they said what? Write a script that compiles a C file but does not link. So which flag are we going to use for this? First thing we have to consider is that the output, the C file name will be saved in the variable. Okay, so the file name of the program will be here. So the output file should be named the same as the C file, but with the extension .o instead of .c. If you can remember, I said pre-processing, compilation, then assembly, right? Assembly is the third phase, right? This assembly stage generates what? An assembly code, and this code is having an extension with what? .o. So whenever you see this .o, just know that it is generated from what? From the assembly stage. It means object, right? It generates an object code. The assembly phase generates an what? An object code. Sorry, I said assembly code. It generates an object code. So this object code ends with what? .o, or in some cases you will see .obj. So this here is just trying to show you that definitely the file compilation stops before the linking phase. How can we tell the compiler to stop before linking? So let's open the file first. Oops, seems like my connection has been interrupted. So let me log in again and I will continue from where I stopped. So let's open the file here, which is this compiler, right? So vi, then paste. All right, so I /bin/bash here, right? So what are we asked to do? We should write a script that compiles. So we are going to use GCC. When we are compiling, just know that we are using GCC. Okay, so GCC that compiles but does not link. So let's go back to these GCC flags and see which of the flag are we going to use that compiles but does not link. Let's start from the beginning. So the first flag here says what? Compile or assemble the source files but do not link. So you can see we can use this flag here. It what? Compile or assemble the source files but do not link. It performs all the three operations, all the three steps, excluding what? The linking stage. So we are going to use what? This flag -gcc here, right? So the first thing we are going to do before that is to what? Add the file name, which is inside this variable called C file, right? And then we just add in our C here. Okay, let me check. I don't know if the C is in caps or small letters. Okay, the C is in small letter. It is case sensitive actually. So let's go back to the task and see. So the file should be named the same as the C file. So the file should be named the same as the C file. So there is no need for us to add this .o and then let's say file here. So what this is going to do is that it will compile it, but it will not link it, and it will save the output of the compilation in this file here, right? But here we are asked that the output should not be saved in another file, right? The output file should be named the same as the C file. So there is no need for this. So we are going to remove this here. So just leave it like this. It's going to generate the code, the .o extension, that's the object file, and it will name it the same as the what? As the C file. Okay, so now let's save and exit. So let's convert it to executable file. Okay, so let's commit. This should be, let's just say task 1, right? Then push. Okay, so now let's check and see if the code works. Yes, so you can see the checks works also, so we are correct. So let's move to the next task here. So the next task here says write a script that generates the assembly code of a C code and save it in an output. Assembly code is generated in what step? After the pre-processing stage, we have the compilation stage, right? So this assembly code is generated after compilation. Is the compilation stage that generates an assembly code. So what is this trying to tell us? This is trying to tell us that we have to stop the compilation immediately afterward, after the compilation stage, right? So we are not to move to the assembly stage, and we are not to move to the linking stage, because assembly code is what is generated after what? After the compilation stage. So here they said write a script that generates the assembly code. So that is the code that is generated from compilation stage. So that is what we are going to do here. Okay, so the C file name will be saved in this variable here. So the output file should be named the same as the C file, but with the extension .s instead of .c. Assembly code normally takes the extension .s. Object code takes .o. So how do we do this now? So let's copy the file first. All right, so let's vi into it. So paste. All right, so /bin/bash, right? All right, so the command is what? gcc. Then the file name is inside this variable called C file, right? So, and we are told the compilation should stop after generating the assembly code. So let's come back to our GCC and see which flag is suitable for that. So we know that this compile the source file but do not link, so we are not interested in this. So let's check this. This stop after the stage of compilation. Okay, so it does not assemble the output in any form or assembler code file for each non-assembler input file specified. So this is what we are looking for. It stops after the stage of compilation. That is, it stops after generating the assembly code, which is what we are told here. It should stop after generating the what? Assembly code. So we are going to use this flag here, -s. So this should be minus capital S. Okay, this should be minus capital S. Wow, I don't know why my network today is very unstable. I have to log in again. Wow, sorry for this inconvenience. All right, so my network has been restored. Sorry for the inconvenience. So let's write the code again. We said gcc, then the file name that contains, the variable that contains the file name, C file, and then we said which flag are we going to use? This -s, because this tells the compiler that to stop afterward generating the assembly code, which is the compilation process. So this minus capital S. Okay, then what again? So let's see the question. So it says what? The output file should be named this with the extension .s. Yes, assembly code is .s. So what again? Okay, so from here, as you can see, they said if the C file is main.c, the output file should be main.s. So it means that the C file name and also the what? The assembly code file name is also the same. So there is no need for adding this -o here, since we are not changing the name of the output file, right? As you can see here, they said the output file should be named the same as the C file. So we are not going to use anything other than this. So let's save and exit. All right, so let's convert it to executable. All right, so let's add. So let's commit. So the message, let me just name it assembler, then push. All right, so let's check this and see if it will work. All right, so you can see it worked as well. So now let's move to the next task. Before that, let me clear my screen here and let me open the file as well before I begin the project here. So vi, then the file name, then what? Okay, so now let's see. It says write a script that compiles a C file and create an executable named C is fun, right? This should be the name of the executable file, and the file name will be saved in the variable this. So we are to write a script, right? So /bin/bash. So we are told to write a script that compiles a C file. So here we are not told whether the compilation should stop after pre-processing or after compilation or after assembling or after linking. So the moment it says an executable, so you definitely know that the compilation process have been completed. It has passed through the pre-processing, through the compilation, through the assembly, and through the linking. So when you are told executable, because executable is the final step, is the last file that is generated after going through all those processes. So from here you know that what you have completed your compilation. So it is the final file that is called an executable file. So here we are asked to create a script that compiles a C file and creates an executable. So the name of the executable, which is the final file, should be C is fun. So the C file that we are to compile is inside this variable this. So let's see. So we are just going to say gcc, then we paste the file name, the variable that contains the file name, right? Then since we are changing the output, we are changing the name of the output to C is fun, we can use this -o here, right? -o, and then the name of the output file in which we want to install. We want to store the output of the compilation, which is C is fun. Okay, so let's save here and exit. So let's convert this to executable. All right, so let's git add. So let's commit. Let me just name it C is fun as well. All right, so push. So let's check and see if the code works. Yes, so you can see the code works as well. So these flags are very, very important. Actually, it helps you do a lot of things. From this, you'll be able to know what you are going to do, and by just reading them, you'll be able to understand what each of these flags does. It's very, very important actually. So now the next task here says, before that, let me open the file. So vi paste. All right, so what does the task ask us to do? It says write a C program. Okay, so this time around we are not writing a script, we are writing a program. So write a C program that print exactly this. Programming is like building a multilingual puzzle followed by a new line. So use the function puts. You are not allowed to use printf. Your program should end with the value 0. Okay, so in this case we are writing a program. Okay, so now let's write the program and see. So the basic syntax we have to do when we are writing a C program, we have to include this function. This is the main function for a C program, right? Int main void. You'll understand why it is void when you go deeper into C program, but now we are just beginning with just this these are just the basics. Okay, so we create a curly braces, and then now we are going to write our code. Every code you are going to write in C program, it has to be included in this main. Okay, it's not that it has to be included in it must be inside main, but the compiler first checks everything that is inside this main file. So all important codes in your file should be within this main file. Okay, it first checks for this main file, for this main function, and then it checks other functions. So now, what are we asked to do? We said that we are asked that we should write a program that prints exactly this. So how can we do that? We are asked to use the function puts. You can just go to your web browser and just type in man puts. This is used to print characters. Okay, it's just like the printf function, but by default this has the ability to create a new line for you. So this says write a program that prints exactly this followed by a new line. So this put function here automatically does that. It creates a new line after after printing your strings, your set of characters. That's just what the puts does. So you can just say puts here. So in bracket, then what are we using? What are we told to copy? Exactly this, right? So let me just copy this and then paste it here. Oops, sorry. So paste. Okay, so it's going to print something like this, but here you can see this is a double quote. If I try to display something or run this function, it is not going to display something like this exactly. it is not. So what I'm going to do is I'm going to add an escape character here. So what I'm going to do is just come here. Okay, so here I will just add a quote here, and then what, this escape character. So what this escape character does is that it tells the compiler that everything that follows after this stroke here, after this slash here, just print it the way it is. Had it mean I did not put this slash here, this will not be printed. This quote, double quote here, will not be printed. But if I use this slash here, it's telling the compiler that everything that comes after this should be printed the way it is. Don't change anything. That's just what this is saying. Okay, that's just what this program is saying. So the next thing is what? After, then it should be followed by a new line. Okay, so we are not allowed to use this, and so on and so forth. So let's come here. So after putting this, whenever you are writing a C file, you just have to end it with a semicolon. Every line should end with what? With a semicolon. So the next thing is what? The next thing is to return the function. So they said return, the program should end with the value 0. So you have to return 0 here. Okay, so now we have done this. But before that, if you can remember, we've installed Betty, right? But before I explain this, let me just run the Betty linter for you so that I'll be able to understand what I will be explaining here. So WQ. Okay, so now let me run Betty on this file. Like I said, every C program we are going to be writing here, it has to be Betty standard, right? So let's run Betty on this file and see. So you can see it says what? No description found for function main. So in Betty, as far as you read the Betty documentation, you'll be able to understand what this error means. So in Betty is just that you have to give an explanation of everything or almost all variables or functions included in your file. So let's do that. Okay, so let's do that. So to do that, you just simply have to come up here. Before even typing the main function here, you just have to what? The first thing I was supposed to do, I will have to include this thing, hash include stdio.h, right? The libraries that include these puts. Okay, or let me check which library includes this put file. I don't know in which library it is, so let me check puts, or let me say man puts here to check the library. Okay, let's see. Okay, okay, yes, it is in what? stdio.h. so this is the file, the standard library for puts, right? So you have to include it. So the next thing we are going to do is just put in the type in the Betty documentation. The Betty documentation begins with this, right? And then on a new line you explain what? The main here, the main, this function here that you are using, which is main. So I'll just say main, then use this dash, and then explain what the main function does. So in this case, I'm just going to say this is the main function. Just make sure I explain this. Okay, so the next thing is what? You have to explain what this return function does as well. So in this case, I will just say return, but your return should begin with what? With capital letter return, right? The return function, I will just say always 0, for instance. Then I will close this with a slash again. So I think this is the end. So let's save and exit. Let's run the Betty linter on the file again and see if there's any error. So no description found for return value of main. Okay, let's go back and see what's the error. Okay, the return here, whenever you are calling the return function, you are not supposed to use this dash. It should be what? A full colon here, like this. Okay, so let's save and exit. So let's run the Betty again. Yes, so you can see it displays the file name. So there is nothing, no error again. Betty is clear with us now. So the next thing we are going to do is to what? Is to add, then commit. Let me just say hello puts, right? Then push. So let's see if the code works here. Oops. So what might be the possible error? Wow, all the checks are not correct. Okay, sorry, I'm supposed to compile the program first. I'm supposed to compile it, so you can just copy this here first, then what? Then paste it here. So this is what GCC wall where extra pedantic puts this. So you just have to go through all these flags here and know what the functions are. This wall where extra, it just makes sure that there is no any error in your file before it finish compilation. Okay, so let's press enter and see. Whoa, so you can see there are some errors here in our compilation. Okay, so you can see there are some errors here. So the first error is what it says, missing terminating character. Let's see how to fix this. VI. All right, so let's come here. I don't know why I did not see this. Actually, we are supposed to put a double quote here as well at the end. Okay, yes, so now I think this will work just fine. So what's next? I think this should fix all these errors, possibly. So let's save and exit. Okay, so you can see it worked. Let me clear and display the result again. So you can see it worked just exactly the way we are asked to print it. This, right? You can see the double quotes at the beginning. So let's add it, commit, and then push. Then let me just name it put, then push. Okay, so I just hope this should work now. So let's start a new test. Yes, so you can see it worked. It's just that I forgot to compile the process initially and I omitted what? A double quote. That's why there was an error. So moving to the next task here. So what are we asked to do here? Let me just open the file first. So now moving to the next task here, we are asked to what? Write a C program that print exactly something like this. So the C program should print exactly something like this. Okay, exactly something like this, then followed by a new line. So we are told to use what? The function printf. In the above we are told to use what? Puts, while here we are told to use what? Printf. You are not allowed to use the function puts. So your program should return 0. So the first thing we are going to use here, the printf function is what? Is inside this directory, inside this standard library stdio.h, right? stdio.h. So you have to include it. So the next thing you are going to do now is what? Is the Betty documentation, right? Is the Betty documentation. So I'll first explain the main function, right? The function main, because I definitely have to use function main. So I'll just say this is, just don't give the description the way I'm doing it here. Okay, don't do that. Give it the description of what the function does. Okay, all right, so this I'm just doing it for explanatory purposes. Okay, so and then the next thing is what? I think that's just what we are going to use, right? Then the return is what? Return, let me just say 0, or let me just say 0 when successful. All right, so let me close it and then int, begin to write my code. Void, right? Void. Okay, all right, so write a program that prints this. We are going to use printf, so you simply say printf, right? Then what? Then your double quotes. The string you are interested in printing should be within this double quotes. So you just copy this. I think I've copied it, right? Then just paste it here. Okay, so this will print exactly what is here. Okay, because in this case we are not going to use the slash we used in the previous task. Why? Because there is no any special character here. Okay, there is no any special character here. So that's why we are going to use. We are not going to use that slash. You can read more about what the special character is. The escape symbol, that is the slash, is used to escape a character, so that the compiler will not interpret it as any other thing. It's going to just interpret it as the way it is. It's not going to change anything, because there are some signs or symbols that when the compiler sees, it knows that it's used that particular sign or symbol to perform its own operation. But if you escape it before printing it, then the compiler knows that, okay, this person is interested in displaying this character the way it is. So in this case, we have no special character here, so we are not going to use this, right? So just come here, then semicolon, right, end it with a semicolon, then what? Then we have to return what? Return 0, right? 0. Then let's save and exit here. So now let's run Betty. As from now, you will keep running Betty on your code to make sure that there is no any problem. So you can see we have no problem here. So now we have to compile here. So to compile, you just copy this here. Instead of typing it, I will just copy it here, then paste. So I just hope there is no errors. Yes, so you can see there is no any error here. So we just say add, then let's commit. The commit message should be, let's say, let me just say where, then push. All right, so let's check our code. Oops, there's an error. Let me see what the error is. The correct output. Why is the output not correct? Let me read the question. Okay, we are told that a new line should follow. Okay, so we have to put a new line here, 5. Okay, we are told that a new line should follow, and I've not included a new line. So you can just come here at the end, before exiting the double quotation, you can just add /n here. So just save and exit. Now I'm sure it will work. So let's GCC into it. Yes. So add, then commit where, then push. Okay, so now let's check our code and see if it will work. Okay, so now you can see it worked, right? So now let's move to the next task here and see what we are asked to do. But before that, let me clear my screen. So now in this task here, what are we asked to do? We are asked what? To write a C program that prints the size of various types on the computer it is compiled and run on. So what are the various types? We have the integer, the float, the character, that's the char, we have the float, we have the unsigned int, long int, and a lot of them, right? So these are some of the types that they are talking about, and the size of these types, they vary from computer to computer. Actually, if you are using a 64-bit operating system, the size is the same, while if you are using a, let's say, 32-bit, the size is also the same, but the size for 32-bit and also 64-bit is different. So that's why they said what is compiled and run on. Write a C program and print the size of various types on the computer it is compiled and run on. So it can be these things are variable, right? So for instance, now the size for integer on a 64-bit machine is what? Is 4, right? So it's in a 32-bit machine is 2. Okay, so this is variable, right? It can change. So now how can we get the size for our own type of computer, whether 32-bit, whether 64-bit? So that's just what this program is asking us to do. So to do that, I can just copy this file here. So let's just go to the file here and paste it. So the first thing we are going to do is what? Is include the standard library, which is #include stdio.h, right? The standard library. Wow. #include. Okay, so now the next thing is what? Betty documentation. So from Betty here, I know I'm definitely going to use the main function. So from here I will say main, then I will just say main function here, just give it a description. So after that, then what again? Then return here. So I will just say 0 on success, right? So if there's anything I'm supposed to add, I will add it later on. So int main void here, void Okay, so now let's begin to type our code here. So let's see from this example what the output is. So you can see this is how it should be displayed: size of char, then this full colon, then the size here. Okay, so how can we do that? I can simply say printf, right? Then my quotation here. Okay, so what am I interested in printing? This is how it should first print this, right? Size of char, right? So let me just copy this here and paste. Okay, so it should print size of char, then then the size, which is 1, and then followed by byte here. So in this case, what I'm going to do is I will add what is called a what is it I'm typing here. Okay, all right, so what I'm going to do here is add a placeholder that to hold the value of of the size, right? That will hold the size value, the value of the size. So I'll just use %lu. The reason why I'm using this lu placeholder is because the size can take an unsigned int or an unsigned long value. That's why I'm using this, right? So and then again, so I will type in by, that's the bytes here, this, right? byt, then in bracket we add the s, right? So then again, then the next thing is to pass the value here. So since this is telling the printf function that here you are going to pass a value, there is a value you want to put in this place here, and this value is what I'm going to type here. So how can we get that value? I cannot hard code this. I cannot say 4. If I say 4, it means that in my 64-bit the value of integer will be 4, but what if it is run on a 32-bit? The value will not be exactly 4. So I will just say use this operator, the function which is the size of operator, and then add in char. That's the first type I want to check for, which is the char type, right? So I can simply just copy this, because I will keep printing all this. I will just copy this here. Sorry, let me just copy it. Okay, so now let's add a semicolon here and then move to the next. So the next one I want to print is I want to print for int. Let's say I want to print for int, so I will just say size of int, just like it is written here, right? Size of int, right? And then and then the full colon here, and then percentage lu. This percentage lu will hold this value here for, right? Percentage lu, and then byte, right? And then bytes. Okay, so after this, what next? So I will pass the value that will place this lu here, which is the size of the size of the size of int. So I'll just simply type in int here. Okay, so this function will run on any system, and it will just get the size of that particular type on your computer. If it doesn't matter if you're using a 32-bit, it will display the size of that type on your 32-bit. If you are using a 64-bit, it will display the size of that type on a 64-bit. So that's why they specified here and say it is compiled and run on any computer it is compiled. Okay, so this is just what they ask us to do. So the next thing is to now we are done for integer here. So now we are done for int. So the next is, let's do for long int, right? So let's say printf. So this, so I will just say size of, right? Size of a long int. Also add this placeholder here, percentage lu, right? Then then bytes, right? So here I will pass the value, which is size of size of long int. So I'm done with this as well. So let's move to the next type, which is we can use long int. Okay, so printf, we can say, okay, size of a long int, right? Of a long int. I'm using this example that they display here, okay? I'm using this for what? To know which of the types I'm supposed to print, okay? It's from here I was able to see that, okay, I'm supposed to print for long int. That's why I said of a long int here, long int, then full colon, then placeholder lu, right? Then what? Then bytes. Okay, so now let's add the value, which is size of, I would just say long int. Okay, sorry, this should be L, sorry, with a G at the end. Okay, so now let's move to the next one, which is what? Which is size of float, right? Let me just copy this, size of float. So printf, right? Then just paste this here, pastes. Okay, so the next thing is percentage lu, right? The placeholder, then byte. All right, so let's put the size of function here, size of what? It should be size of float, right? I hope you understand it. So then what again? Then we return our value 0. Okay, so I think this should work now. So yeah, we were able to what? To print the size for char, for int, for long int, long int, and also for float. So this is going to say what? This is going to display exactly something like this. It will first display size of char, then what? Percentage lu. So this percentage lu will be replaced with the value that is printed here, which is the size of char, which is 1 here. So it will display it will replace it with 1 and display this here, and then what? And the bytes here, and then it will display it. So let's save and exit. Okay, so hope this should work. Let's run our Betty first. 6. All right, yes, so Betty works. Okay, so the next thing is to what? Is to compile, right? -o. It seems like there is a package you need to install before running this, but let me just try this and just say trial. Let me just name it trial. Let me just compile it like this. So there is an error, size of long int. So what does this say? C9 does not support long. So that is why we are told we have to install this package on our machine before we'll be able to what? To do this. Okay, we have to install this before we'll be able to what? To get this. So actually I don't have any idea on how to install this package, but I will check. If I got the idea, I'll be able to share it with you people, or if anyone have the idea on how to install this package here, that person can please share this on the description or the comment section of this video, so that others will be able to benefit from it. Let me just view the file for you. This is the code. This is what you are required to do. Okay, all you have to do now is just to compile it. Let me try using just GCC to compile the file and see if it will work. GCC, then what? Okay, so let me just say GCC, just the file name. Okay, so it seems like it's compiled now. So let's just try adding and committing. Okay, so commit. Let me just name it size, right? Let me say push. So let's see if it will work here, since we've compiled it normally using the GCC. Let's see if it will work now. Okay, so you can see there are some errors here, right? Let's check the detail of the errors. So the output for a 32-bit machine is not correct, and the output for a 64-bit machine is not correct. So now let's move to the next task. So this task here says write a script that generates the assembly code Intel syntax of a code and save it in an output file. I've not developed a code for this as well. I'm working on it. I'm finding it very complex to come up with the idea, okay, but I will make sure I get the solution, the code, and I will drop it in the description of this video. So moving to the next task here, I hope this should be the final. Yes, this should be the final task. So the next task here says we should write a program, a C program that print exactly something like this, right, followed by a new line to the standard error. Okay, I'm sure you all know what this standard error is. I've explained standard error in one of our previous videos. We have the standard input, output, and the standard error. The standard error takes in the value of 2 to address it, right? So actually I'm still working on this as well. So I will develop the code. I'm almost done with it. I can see it here. It's just that I'm kind of busy to complete it, but I will complete the code. As soon as I complete the code, I will also drop it in the description. Thank you very much. Till we meet in our next session.